Hi guys, in this video I provide an introduction to templates. Templates in C++ allow you to use generic types in your program. Templates can be used for functions and for classes. In this video I'll only use templates for functions. I have a basic example that illustrates the idea why templates are useful and how to introduce templates to your program. At the top I have a function prototype named add. This prototype has two integers as parameters, and the return type is an int as well. Below the main, this function prototype is implemented, and inside the main, I call this function, I pass in 5 and 3, store the result in a result variable, and output it. When I run this, it computes 5 plus 3 and outputs 8 as a result. Now, what I want to do is, I want to add the same function that computes the sum of two floats. So I would use float result2 add 5.3, for example, and let's say 7.2. These are two floats. Then I want to output this, and the problem is when I run this, currently it would just call the same add function as integer. So what could I do here? What I could do is I could overload this function and then specify a float, and then also implement it below here float as well. Now when I run this, this will now compute float and it gives me the right result. But what did I just do here? Essentially, I copied and pasted the exact same algorithm and code that I have in the first function, and I use the same code in the second function. So imagine this code here that the function computes would be 20 lines long. It will result in a lot of code duplication, especially if I had to overload this function a third time with another type. So this is really where templates come into play. When you have the same code, but the only thing that changes is the type. Everything else is the same. The algorithm and the statements inside your program are exactly the same. So instead of overloading this function with a different type, I will use a template. So before the return type here, and typically the line above it, I use template, then open angular bracket, and then type name t. T is really just a placeholder for a type. It could be anything, but most commonly T is used. And then I can use it anywhere where I need to in my function. It could be just one argument, but in this case, I want to add two values of the exact same type, and the return type should also be that type. So I just plug it in wherever I need to have a generic type. In this particular case, it's the return type and all the parameters, but it doesn't necessarily have to be the case. Now with that, I have to do the same at the implementation below. So here I have to specify the template again and replace the int with a t. Then when I run this, you can see it computes one time for integer and one time for float. Now how did this work? So at the first function call, I specify two integers. So the compiler is smart enough to determine the type here, and then use this type for the parameters at the function. And then it will be using integer arithmetic to compute the result. For the second function call, the compiler will determine that it's a float and then perform floating point arithmetic when computing the sum. So this is how you use templates in your program. You simply specify template, open angular bracket, then type name t. You could also have more than one template. So I could do type name p, for example, or a, or hello, whatever you want to name it. Typically t is used, or s. And then if those are different arguments, I could just put it here and say, if I do the same below, this one would be an example where I use two different types, but they could be the same. So running this again, this works as well. What I could do now is I could call this with a floating point and an integer, for example. If you have complex functions and the code is exactly the same, but the types may vary, that's the case where you want to use templates. And as I show you, you can use a single template when you expect all of these parameters or return type to be the same, or they could be different using different templates. I hope you enjoyed this video. Thank you for watching.